Okay, this is the main screen of Brain Simulator 3, and on hundreds of occasions, I can say Fido is a dog, and there's Fido as a dog, and that's how it would show in the graph. Okay, let's get started officially. I want to welcome you all to this presentation. I hope you came with lots of questions, and hopefully we'll give a couple of answers. I want to start with just a review of the regular status of things. The society is still growing. We've got 700 members. I sent out in the mailing just a reminder of this meeting. And Firas and to some extent Saeed have put together a Discord server that I want to make sure you're all aware of, because it is getting to be a really active conversation about various ways of doing things. And so on the website futureaisociety.org, there's a link in the upper left to our Discord server, and it's definitely worth a visit, and I hope you will all have an opportunity to go take a look. Another thing is that user David Freely, who's, and Zaid, I see you've come and gone, so I wanted to send out a kudos to you for your participation. But David Freely's been working on documentation, and I wanted to give you a quick look at what he's been doing, and hope that you'll be able to be interested in participating and making it better. This is our GitHub screen. I hope you can all see that. And across the top, we have code, and now there's a new entry called Wiki. And the Wiki, if we wait patiently, there is blocked out documentation. And some of these have got entries to them, and some of them are blank. And hopefully, if you have an opportunity to paw through this a little bit, you look at some of the ones that are blank and fill them in. And here's architecture. He's done some AI, and I know he's working on more extraction of information from everything that we've ever written in books or on the website or in the Discord server, and the transcripts of all the YouTube videos, and is extracting that into documentation, which with a little bit of effort on everybody's part will turn into something really valuable. And I hope that you'll all have an opportunity to check that out and take a look. So it's on the GitHub server for BrainSim III, and it's that entry Wiki at the top. So it's really easy to get to, and it's unbelievably easy to edit. You do have to be a member on GitHub to be able to edit, but you can just click on a page and say edit this page and add something. And so if you find out a piece of information on how to run BrainSim 3 or even BrainSim 2, this is a good place to stuff it. You can write it down. This is all about participation. This is an organization that's growing really well, and I hope you'll all have an opportunity to participate in the software if you can, on the wiki if you can, in any other way you can. I'm looking forward to it. I did want to talk about the YouTube channel. It has in the past done really well, but over the last 2 months, the viewership is really deteriorating. So I'm hopeful that you will all be able to contribute ideas for topics or style or improvements. But one of the things that I notice is that the way the YouTube algorithm decides to announce videos is simply not working for these types of videos. And I can show you a screen, for example, over here. For those of you who are not familiar with the internals of YouTube, you can get statistics on everything. And this is a view of how many times this thumbnail was presented. And so it started off not presenting it, and then it presented it to a lot of people, and now it's presenting it to fewer and fewer people. But the total number of presentations is only 5,000. This is a channel with 22,000 subscribers. So you know that it's not even presenting it to a quarter of the subscribers on the channel. And so we need to think of ways of if we want to get more members in and more contribution to the process, we need to think of ways of making this a little more viral. So if you want to post a link to this video to your friends or to your enemies on Facebook or anywhere, any other place, that would be grand. And if you want to make suggestions on how to make the whole channel perform a little bit better, I'm for it. But the key is that the YouTube algorithm just doesn't know what to do with this video, because it's not about cats and it's not about politics and it's not really about AI in the general sort of sense. You know, I could do videos on backpropagation and how to apply a neural network, this and that, and I would get 10 times the viewers, but that isn't the point. The point is, let's do something that other people haven't done. And I've run into this in ChatGPT too, that I say, I want to write a program that does this, and this is something that's never been done before, and ChatGPT is really lost. If I want to ask ChatGPT to write a program that works the way everybody else's program works, then it's great. It can write the whole program for me. But unfortunately, if you want to do something new, you kind of have to write it yourself, which we'll get to in a moment. Now I want to show you a quick demo of the new features that I've put into Brain Simulator 3 over the last month or so, and what I've been working on. And I think, of course, it's fascinating, but I think all this stuff is fascinating. And here I'm sharing a screen that is somewhat covered up, so I can't quite see it. There we go. Okay, this is the main screen of Brain Simulator 3, and on hundreds of occasions, I've said, well, if you want to enter data into the graph, there are a number of displays. This one on the right is the display of the graph contents, and I can say Fido is a dog, and there's Fido as a dog, and that's how it would show in the graph. And if I wanted to say Fido has fur, I can say Fido has fur, and this is added. This is the confidence that this is true, this relationship. And this is displayed differently than Fido is a dog, because is a relationships and some others are special in that the attributes are inheritable. So if I was to say dogs have fur, then Fido would have fur by default. And I've talked about this a lot. And then I want to move down to this next screen, because this next dialog box, because this is where things get more interesting. This is how you would search for information. So if I wanted to ask what has fur, I'd say it says Fido, and it has a score of 0.81. The score is in arbitrary coordinates. We're not going to think about that for a moment. But the problem that many people have brought up, and this is a perfectly legitimate criticism, is, well, how did this information of Fido being a dog get to be there? And I've pushed that 2 layers further on towards a solution and I'm going to start completely again from scratch. And I'm going to say that because all I can see, how do we want to say this? All you can see in the world, if you look out into the world through your eyes, all you can see is attributes. You can't actually see a dog. You can see legs or fur or teeth or whatever, but it's up to your brain to figure out that this combination of things is dog. So what I'm going to do is now I'm searching for what has fur and I get no results. And I'll add a few more parameters. Has a tail. Oops, misspelled tail. So we'll just take that out. There are ways to use the system to take it out, but it's much faster to just do it that way. And I can just take that off of the list of parameters. So what we're doing is we're building this list of attributes we're going to search for. He can bark, and it's brown. And I'm searching for these attributes. I get no results. And then by some yet to be determined process, we'll say, when we get no results, we're going to learn what that thing is. And we say learn, and it says, here's this new object. It's unlabeled because we have no idea what it is, but it does have these attributes. And I've added a little hack so I can say this is called Fido. And all that does is it adds a label to that node. And that makes things a little more understandable for us. In your brain, there are no labels. So this is just so we can understand what this is. Now, if I add another parameter and say this is a different dog, and this dog is black, then it will search, and the only thing that's in there is Fido, but it's finding Fido with a somewhat lower score than it was before. And so we're going to say, no, this isn't Fido, and it will say, aha, I'm building this other new thing. And it says these things have got common attributes of can bark, has fur, and has a tail. So if I say this thing is called Rex, now I have this thing called Rex, and you can get a better idea of the scores that are coming out with as we do this search. So we're searching for these 4 attributes, and it comes up with Rex and Fido and UNL1. That's unlabeled item number 1. If we take off the is black, now the number 1 hit is going to be unlabeled 1, and I can say this is called dog. And so now I've ended up, what you can see has happened is I've ended up in the same place I would have if I'd keyed in all of this information manually, but I've done it only by observation. And what I want to do is to stop for a moment because I've breezed through this in a very short period of time and ask if there are any questions about how this has to work.
Well, you're trying to figure out generalization, right?
Exactly. I've shown here, here's how your brain can generalize on a very simple sort of algorithmic process. Okay, so yeah.
Oh, go ahead.
So we've generalized the fact that Fido has dogs have some properties, and these properties are common to dogs. They can bark, they have fur, and they have tail. And the distinguishing characteristic of Rex is that he's black, and the distinguishing characteristic of Fido is he's brown. And whenever I put in some sort of attributes, they get some kind of weight associated with them or confidence value. And so this graph is beginning to build up the generalization process that we might begin to call one facet of intelligence.
Charles, how do you determine whether it's a score of 1.0 or 0.9?
It's just hard coded. If it comes from this window, it's
Oh,
No,
okay.
but
Well,
if
here I might have said this.
yeah,
Here's a heuristic, which is if you directly observe it, then it's 1.0. But if you're inheriting it, it might be 0.9 because inheritance is a little less direct.
yes, and the way things work is that as you inherit, um, the the confidences are multiplied. So if you
Uh-huh.
have a 0.9 confidence that you're brown and a 0.9 confidence that you have fur, you're only going to get a 0.81 confidence that you're a dog or that you're a Fido.
Uh-huh.
And
Mm-hmm.
so there are two questions that come out of this. And the first is, well, what's a good way to calculate these confidence values and how do they accumulate? And I thought initially this was going to be pretty straightforward, but it turns out that things like if you only see two attributes, if you only see fur and a tail, for example, you know that it might be a dog and it might be Fido and it might be Rex, and we'll assume that it's a generic dog, even though it's assuredly Rex, because you pretty much know the color of something when you see it. And so this whole process of figuring out scores is fuzzy at best.
I'm very familiar with it. I do a lot
Okay.
with scores, so I know
Yeah.
what you're talking about.
The question of when to press the learn button is fuzzy at best. And the question of when to press the no button is fuzzy at best. And these are problems that if we can solve these problems, a whole lot of stuff is going to fall into place.
I'll tell you another clue that I use that maybe could help. Let's say that barking is a really definitive kind of characteristic as a dog, where it says color, it could be black, white, brown, orange, doesn't really matter. So some way to score the attribute of barking to boost its importance when you're adding up whether it's a dog or not. And I do and Justify, I do this I have criteria, and each criteria has a weight as well as rationale and other things. So we could sort of take for example barking and give barking itself a weight of 3, whereas color is only a weight of 0.5 or something like that, right? And it's still important. And if you had a whole lot of other attributes and the thing didn't bark, well, maybe we have a silent dog and that could still work. But you get this score on the attribute or on the criteria.
Right. Yes, and I think the software does this. We just need to figure out how to assign that. And I think there should be a fairly easy automatic way to assign that when you have 20 different dogs and 20 different animals.
Good. You can learn the weights of these.
That it should be able to determine what's important on its own.
Good. When you have a large enough sample size, and then you have to, figure out what's the large sample size. And, when I go to Amazon and look at a product, if it's got 5 stars, but only 2 people rated it, I'm like, I'd rather take something that had 4 stars, but 100 people rated. I prefer that product. So that's a scoring mechanism that takes into account the sample size.
Yes. Open question.
Well, yes. Learning is novelty.
Yes.
Novelty. In other words, if you're surprised by something, that's when you learn.
Okay. So,
I mean, and if you want an algorithm that will tell you whether something is novel or not, there's, something called an isolation forest, which will do that pretty quickly. I don't know if you're familiar with those or not, but that's an algorithm that detects novelty.
Mm-hmm. And and we may have ways of detecting novelty that are simply, if it's already in the graph, it's less novel than if it's not in the graph.
Well, if you think about your brain, you have stuff that comes in and it does a lookup, and if it finds something that it's already seen, it's not novel. In other words, you know, as this stimulation comes in,
right.
and if it doesn't match, then that's a novelty, and novelty is important for navigating around the real world.
Mm-hmm.
But even if it is in the graph, you can confirm that it's in the graph and strengthen your current concept, and that's a kind of learning also.
Exactly, and that brings me to demo number 2, which is here. And if we go to this other file, and this is all the same questions in a framed in a different problem. So this will take a moment to initialize itself. This is, somebody said, well, can you do MNIST in this? And I've learned now from having played with it that MNIST is a particularly bad example. But what I've done now is to say, I'm going to have a visual field, and it has pixels. And in this instance, for simplicity, the pixels are either black and white. And now you're going to want to recognize things in these pixels. And so I've got this almost horizontal line, and I'll click this and its angle will change a little bit, and we'll see here are the things that it sees. And it sees these 4 boxes, and these are the actual pixels that here I'm using. This is all in the graph, so I can come over here under unknown object and say it's got a box 1010, and I can right click that and fire it and say that is the connection pattern of this object, of this node. And so, for example, I can come down here and it automatically created these, and I can fire it and say, well, that would have been this if it was found. And so every time it gets a novel input, it says what, I'm not sure I'm making any sense of this, but these boxes are all just part of the graph. So this is the beginning of answering a whole slew of really valuable problems, like how do you represent graphic information in a brain, and how might it learn, and when do you decide when it's going to learn, and when are you going to forget? Because obviously if you learn something, you only want to remember it if you've seen it a number of times. So if we go on to the next one, it sees here we've got a nice 45-degree line, and you get this nice orderly setup of graph items that it's fired, and you can see that it's fired them over in this picture too. And so I've just gotten started on this vision, and this is where I was talking to John before we got started, where I am the evolutionary algorithm, where I write some code and it doesn't work, and then I write some new code and it doesn't work, but it's better than it was before. And maybe we could figure out that obviously this has to be built into layers, and we could make things run a little bit. Before we go down that rabbit hole, I want to scope the size of the problem. You know, we can just look at a picture of the brain and say visual cortex, about 1 billion neurons, give or take. Certainly more than 1 million and fewer than 1 trillion, but say 1 billion neurons. And I've said that nodes in the graph take 100 neurons apiece, give or take. But after you've learned all of this stuff, learned something in a node, you don't need all the overhead that the node needed in order to be able to learn. So maybe, I mean, I certainly am not learning how to recognize boundaries anymore, or the letter C anymore. I've known that for 60 years, so I've got that pretty well down pat, and it hasn't changed. So probably all of the neurons that were needed in order to make that node capable of learning may have atrophied because they haven't been used in decades. So maybe they're just gone, and maybe that means that the billion neurons of the visual cortex is good for 100 million nodes. And so that's the scope of the problem, saying within, and I'm currently working on the MNIST 28 by 28 scale, 28 by 28 pixel array, and visual pixel array is, let's say, 500 by 500 or 1,000 by 1,000, but because it's nonlinear, it's difficult to say. And so the question is, so for my 28 by 28 array, I should be able to execute vision in 1 million nodes. Well, 1 million nodes is something that I can do tangibly, and I should be able to, if I can solve the problem, then it all fits together, and I will know about how to learn and when to learn and how to forget and when to forget, and what makes something novel and what makes something discardable, because obviously there are many more pixel patterns that you cannot recognize than that you can recognize. You can only really recognize lines and corners and things, and the snow, the snow of random pixel patterns is unintelligible. So that's where I am on this, and I'm really having a lot of fun making it work. So I'm hopeful that something interesting is going to come out of it, and I don't just flail around for another couple of weeks or months and make it run, and come up empty.
So Charles, are you saying that the hardware of the brain compiles this stuff into a smaller set of cells, let's say, that can achieve the same result as the tons of neurons that are very flexible?
Oh, sure. I would contend that yes, and Heather wants to chime in on this.
Yeah, well, at the first level of the hierarchy, the brain is a little bit more flexible because it's literally picking up things with different resolution in the central field and the peripheral field, and it has special columns for motion sensitivity out here and for resolving shapes in the center. And the thing is as you move up the hierarchy, then they literally develop columns, which are like what Charles was describing when you build up a memory of what are the components of a dog, right? Mm-hmm. Well, you literally build up a categorical representation of visual things. And then you can do cross-modal things as well. But in the visual and the auditory system, you build up an actual set of specialized neurons at a high level that are just for that. And so that's why later you can actually grab a category relatively easily with only part of the information, because quite literally you have the representation up high, and because the early level brings in some information, you have enough to grab it. And you can get interference too. That's another whole story, but I won't go there.
Yes, but to stop me if I'm wrong, Heather, I presume that if you have neurons that you never use, that those neurons are going to fade away on their own and maybe be repurposed.
I mean, there's an idea that you have, well, developmentally you have what they call an overexuberance of synaptogenesis across all of the high level brain and all the brain, and then basically you prune and you strengthen those synapses that are doing functions that you have repetitively interacted with, and therefore they're strengthened. And yes, you're right. If you never ever, like if you were blindfolded for an entire year, yes, you might have some issues with some of these the synaptic strengths changing, right? But
Yes.
it doesn't mean that they all go away, because in theory, you have in the high level regions, you have old memories and they can be maintained in theory. But the problem is you have to keep the brain clean and strengthen the synapses.
Yeah, and my speculation is that if you want to have really general computation in the graph, each node has to be capable of figuring out if it's the node of interest, or if it's going to learn something, and how it's going to learn something, and what it's going to hook to. And obviously in your visual cortex, all of that functionality is unnecessary, because within the very low levels of your visual cortex, you know what a boundary is. And you're not going to learn what a new concept of boundary is. And you know what a corner is. And certainly when you were 10 years old or 6 years old, you learned what the letters were, and you got that level of information. But after you've learned all of that, you're probably not going to forget what a C looks like. And so there's no need to maintain all of the functionality you need to be able to make those nodes general anymore. And all of that neural hardware could be repurposed to something else. That's a speculation on my part, but it stands to reason.
Except there's new fonts that you've never seen before, and you see a C in italic or some weird serif font, or you see that little C that's in French that have a little thing hanging down. It's kind of a C, but not really. Sure. And
Sure, you can add a new character, but the one you've already got doesn't need that learning functionality anymore, because you're done learning about that character. But you
I don't know.
You'll need some nodes hanging around capable of learning additional characters if you want. You can't let them all go away.
Could I argue that psychosis is actually that process happening? So a lot of people that have done too many hallucinogenic drugs have a psychosis where they dissolve the letter C from their mind. They do dissolve those connections. Those do deteriorate. I don't think that they ever go away, though, like you're saying, or that you just gain more of them. Like, people learn 7 different languages. Rare, of course, but they do, with a whole subset of skills and jobs and everything else. So I think we have just not found the capacity yet for what we are. But I'll chime out. But yeah, psychosis is an interesting one. On the other side of that, it happens to adults and people and dementia. There's lots of examples of that deterioration, and it's kind of cool.
Yeah. Yeah.
Well, if you're trying to do a lookup, isn't it just at some point using spiking information as a lookup, as a combinational logic?
An excellent point. When the system is done learning, it's a really, at the very low level of vision, it's a straightforward feed-forward neural network that you put in some data and it goes through a number of layers and you get an answer. And I don't see that there's any other possible way it could work, especially at the speed it works. And what you'll see is that there's a tremendous parallel between the graph system that I'm talking about and the spiking system from BrainSim II. It's just that we're thinking one level higher, so we get to invent new parameters as we go.
Well, it sounds like the linkage is that BrainSim II is a lookup into BrainSim III.
It could be. That would be one way to look at it. And certainly, I have in BrainSim 2 implemented these graph-like things, and so I'm confident that it's certainly a possibility. but it is, if you were to say you wanted to do things as Fry was talking about the way you're going to handle weights and scoring and all this other stuff, modifying the way those are handled in individual neurons is beastly in software. But if you do them in BrainSim 3, we can just invent a parameter and do the arithmetic and be done.
Yeah.
Yeah, but that's the hard part, isn't it? Is to figure out how the brain uses time to do its looking up.
Right. And so I think, I mean, I've done what I'd say is really rudimentary, low-level stuff, but at the core, it's doing exactly the same thing as Fido is a dog. And I would contend that your vision system is really at that level doing exactly the same thing as hearing and the auditory processing, except instead of working with pixels, it's working with specific combinations of sounds. And it's having to work over time instead of being able to look at a static image. That sound makes no sense in a static situation.
Yeah.
Yeah, but doesn't the fovea move around? So isn't vision a time sequence as well?
That's an excellent question. What do you think?
Of course. I mean, in other words, I think everything is temporal. So in other words, whether it's audio or visual, it's a sequence. And if you say, well, you perceive it in a static moment, well, you don't. I mean, your fovea is moving around, and so that converts it into a stream.
And obviously, your hearing doesn't do that. Your vision is moving from place to place and filling in a complete map. And hearing kind of takes syllables at a time, and to the extent it's filling in a map, it's just kind of a nebulous meaning as you try and make sense out of what you hear. So,
well, there is predictive coding. So there's for the dorsal hearing system, you have motor systems connected to your auditory systems, and quite literally, you when you listen to speech, you actually imagine the motor predictability of the next component of speech, and it basically plays out in your brain, and they recorded it. And it's, you know, if something comes out different than you expected, then you get a surprisal. They call it an error.
So to some extent, you hear what you expect to
hear.
What you have memory for hearing, and that is temporal. That's a very temporal thing. But with vision, I mean, in the periphery, you rely. So the periphery is specialized for temporal domain. Your peripheral vision is 100% specialized for temporal domain, whereas your fixed foveal vision is very high resolved, and so that's why you have to use a cod around to build up a working memory of the room at a high resolution. That's what we do. And
you can play with it.
Yeah. What?
You can play with it. I sent a YouTube video to the chat.
I like it.
You can just read the word Yanny and then listen to it, and then read the word Laurel and then listen to it. Your brain hears the sound's the same sound, but your brain translates it to both of those by some priming, right? And that's like magicians. Magicians prime you with visual and auditory priming, and then they know what you're going to do. Yeah. They trim your trees, they trim your attributes before you even know that, with visual cues that you don't know. And it's pretty, I think that's very underused in most. I come from game development, so magic and that philosophy and brain development and the science, like, that underutilized in a lot of the fields so far. Like some of the fields I've been in for years act like they're old, but they're not even old yet. Like they're gonna be crazy in the future. So, but yeah, play with that one. It's fun.
I have to go. I'm so sorry. I love the conversation, and but I have to go to the EEG lab.
Good.
See you guys. Gotta
Do you
go.
have
go
any
for more
links?
from Brain.
Sorry, before you go, Heather, do you have anything about interference? Because that was something I have not heard on any of Charles' videos.
Oh yeah. Well, yeah. Interference is I mean, it's a thing. Yeah.
Yeah. Okay. It sounds like a
yeah.
big thing, and I'm interested.
And
So
the interesting thing is you can have interference from the real world, right? That's feed forward, but you can also have hallucinations like in schizophrenia
yeah,
and Lewy bodies syndrome, and those literally happen partly because your top-down control has changed, and so you get literally release of inhibition from areas, and they get tickled and they have a hallucination. So yes, that's an interference that's distinct from an interference that's a real world interference. But yes.
Does synesthesia play any roles in interference?
Oh, synesthesia is a very interesting one. Yeah, it can.
Because if it's really exaggerated, it can totally interfere, right? I just wanted to know if I'm thinking in the same way. Okay.
No, it can. But then the other thing too is you have to understand the real world, like what Charles likes to simulate oftentimes with the robot. I've seen it in person and I've seen it work. It's beautiful. But the point is that in the real world, we're not only just taking in visual information, we often have masked information. So the picket fence solution, when you see a horse behind a picket fence, why does your visual cortex see that? Well, because your visual cortex is built up columns for every little pixel, but then it also has a layer that connects collinear parts of the image so that you build up the shape of the horse. And so we are able to build up that shape in spite of the fact that the picket fence is blocking it because of, that's nature. We have blocked input all the time, right?
Cool. Yeah. We see it in helicopters. We see it in things that reverberate, like anything spinning at certain frequencies, right? Like that matches us. Yeah.
I agree.
Cool. Thank you so much.
All right. I'm sorry I have to go. Bye.
Well,
bye, guys.
Thank you. Glad to talk to you. So,
I have a concept that might unify some of the stuff we've just been talking about. So, Charles, I watched your new learning video. Okay. And that's central to what we're talking about. My first question about it is, you said, say we've got a brand new world and we see something that has fur and a tail and a nose or something, and we create this object, okay?
Yep.
That has those attributes. It's unnamed. We don't know that it's a dog or anything. It's just, there. Okay, now suppose also in the picture is a bird flying by, a cloud, some grass, all this other stuff. How do we know to take the fur and the tail and the nose and put it in one object and not include the grass and the bird flying by?
That's excellent. And my speculation is that the answer is attention. And you pay attention to things that are clustered together, like the attributes of the dog. They're all attached, but this is all speculation.
Yeah, good. So I thought of that, and I think you're right. And if it moves together,
let me add to that it has to be serial. That the way your brain, the way the graph works in a computer, it could be in parallel, but the way your brain searches by firing neurons, you cannot run multiple searches through the graph at the same time because they will interfere with each other. So you have to look at the dog as a separate entity from the bird at a different time. So you have to have attention that shifts from place to place, because you have to look at things serially.
Well, okay, they didn't quite match, but let me just say this. If things are co-located, that's a good indication that they form one object, right?
Yes.
And especially if they move together, like the dog is running across the grass, well, the grass is static, the dog is moving. So that's another indication that all those attributes are the same thing, okay? Now, let's imagine a dog is wearing a collar. Okay, so it's co-located, it's moving with the dog, right? And it's a blue collar. Well, no dogs have blue fur, so that's really different. So you could distinguish that. But supposing it's a black collar, So this is what I'm having a hard time with, figuring which of the attributes that you're seeing are clumped into one object, as opposed to other ones.
Is the horse with a rider a single entity, or is it multiple entities?
Another good example.
Is every single piece of wood on a boat the boat, or is the boat, right? Yeah. It is a philosophy, and I think it's each person. But we must have a groundwork somewhere, right? We must have a base that builds from it.
Yeah, and my suspicion is that this is a question that applies at multiple levels. I think dogs can do this and cats can do this. The cat knows the difference between the other animal and the other animal that has something associated with it.
But movement is important for survival. Think about insects. They're
right.
mostly geared towards detecting motion. So in other words, maybe we're looking at this from too high a level. Maybe me looking at static images is the wrong way to look at it. And exactly.
I should start with vision.
Well, I think it's more also faces. Look at faces and people. People and faces is the abstract. So you go the opposite way. You guys, like, if you're going specific, if you're trying to look what the abstract is, go abstract. What do we fail at the most that we identify and we're bad at? And that's faces. We see faces in trees. We see faces in stars. We see faces in everything. Yeah. And so that's us failing. So there's a giant category for faces that's bigger than everything else. So even when you're saying dog and color, you're not looking for dog and color. You're looking for a face to see if it's going to attack you. And if it's smiling or if it's not, and then you're looking for a tail. Like you say tail a lot. I like that one because we do look at the backside of things. Is it showing its backside? It's a weird pattern, but once you find the face, is it showing its back? You can't know until you find the face, right? So
I like this idea, but how do I translate that idea into the code that I'm working on?
You can't really. I've been working on this for a while too. I've been trying to abstract everything of humans on Earth into 8 categories because I use an oct tree for my visualization. And I stumbled upon your videos, Charles, and they gave me that boop in my brain for seeing how the oct trees can categorize downwards to attributes from groupings, and how I was so obsessed about how do I specifically put individual items in. But it's an encyclopedia I'm building, and now I just have a lot more files that can sit in multiple spots. So on a computer, that's way better for a computer. For your brain, with little tiny, literally organic gloopy gloops touching each other, it's way better. Like a tree works better in the soil than it does in the ocean just sitting there, right? Like it can't grow. So a computer uses ones and zeros. So I think you're still having to translate it down. So I've just used many 500 kilobyte tiny files that are all linked in together. So you can go down to the deepest attributes and have all those files still at the bottom. But the categories contain lists of what's below it. So like once you get there, you're no longer searching everywhere except for below it. And also visually inside of it's an oct tree. So you're just cutting one cube into 8 cubes, and each cube fits in 8 cubes. Using that formula for searching with a computer allows it to just visually it's really cool. So I'm an artist. That's where my background comes from. But 2, it allows for the interaction and looking at a giant database of objects. So I'm trying to tackle something different than you are, but it's starting to merge with things I see online, and I'm starting to I don't have a university background, so I'm starting to hit points where I need to learn a lot more. Or find people that know a lot more. And your videos inspired me quite a bit to use this attribute tree system in my work, in my game engine.
That's great. So maybe I ought to go make another video.
Yes, you should make lots of videos. I think the thing is you should just pump out a lot of small ones and large ones. That's the big thing for YouTube. Yeah, definitely.
Can you tell us the 8 core categories?
I can bring them up if you would like to see. Yeah.
I'm guessing one is a face.
No, it's not. No, no, it's quite a bit different than that. So just give me 1 second here. I wasn't planning to show anything, so.
Well, just the names of them. I don't care about a visual representation.
Oh, okay, sure. So right now I have them set up. You can actually go to them, but I won't load that up yet. So I got my old one and my new one. I've gone through quite a few. So we got concepts in mathematics, geography and place named instances, humanity and society, life and biology, nature and physics, perception and communication, potential and void, which is where all your personal and user data is stored. All the stuff that's going to get pushed to the official line is stored. So there's like multiple layers of having to store user data and like things you don't want to publish to it. It's a imagine a social encyclopedia. I think I've come up with a way to figure out how you get that. You guys have been talking about how you get the variance and the how you figure out what's what. You just need more people, like you guys said. You need more people, but you need it to be cool and popular and people want to vote on things. So you need a way to add attributes. You have like people that will add attributes to your system because you're building a database, right, of the world. Something that could be used on Mars, right? That's what I picture. And I'm building the visual interface for it, basically. So that's where it's kind of cool. And you just have, you really have you have to abstract more. And it's hard for people that really concentrate, I think, and learn a lot in a specific field to abstract because it's you can't, your brain isn't built to do that. I've done artistry and I was a TA technical artist and I've done coding and I've put on a lot of hats and I've never gone too deep into one thing, but it's given me an enlightening introspective of how there is a balance to abstract that you are very close to. Your tool is very close to. It's like very sciencey, but it's very close to being something that is so useful. I have one question before I just shut up. Is do you have an API or do you have any plans to put in like networking in your tool so you can Dockerize it and then talk to it like a server?
I think it's already there, isn't it? There's some TCP code.
Is that in? You can do that, like to add attributes and to do stuff without the interface?
Well,
I haven't installed it.
He's got a network interface built already.
Cool.
Essentially, and are you a Windows guy or a Unix guy?
Both Mac, Windows,
Okay.
Linux, doesn't matter.
Well, if you're a Windows guy, things are a lot easier. The actual graph itself is a separate entity from the user interface, and it's a DLL on its own. Okay. And all of the interfaces to that DLL are exposed. And although it's about 3 revs, three revs out a day, there is a published interface which you'll find on the website. Is
that on the new GitHub wiki? Because I saw you put that. That's really cool.
No. Unfortunately, we haven't figured out. There's the GitHub wiki, but the API is one of these self-documented things that spits itself out, and we haven't figured out how to transfer from that to the wiki. So it's on the website under Technologies BrainSim III. There are a bunch of links across the top of the page, one of which is UKS documentation, and it will take you to the API documentation.
I'm loading that up on a tab to save right now. Thank you.
Okay. Okie dokie. Well, we're coming to the end of our hour. So does anybody have any last words they would like to become famous with? Any last questions? Well, I want to thank you all for coming. I certainly appreciate it. And I look forward to talking to you again. I'll do a little software, do a couple of videos, and any contributions and ideas for videos and things like that, I'm very interested in hearing from you, and I hope to see you again and talk to you again in the future. Thank you very much. Bye-bye.
Thank you, Charles.